Afternoon class, it's Sir Gerald. Again, we'll be talking about yet another topic here in Math Zero. And this topic is actually more on, or the concept of this topic is about division of segments, or by segments, we are talking about line segments. So that will be the concept we are to discuss today. So in that, actually, by dividing up or division of segments, we are actually finding a point or looking for a point or a specific point or specific ordered pair in the coordinate plane, which is in some sort of proportion from two other points. Like for this example, we have here find the point B on the line AC such that the ratio of AB to BC is 3 to 1. Okay? So if you have any idea on how to solve this, you may want to pause the video and try this on your own. Okay. So some of you may consider using distance formula to find that point B actually. Uh, I think some of you may have done it, so it's not entirely incorrect, but the issue on using the distance formula and then just dividing it by in a proportion of 3 to 1, we will be encountering a problem wherein we cannot find the specific ordered pair that will locate our point B. So let me just redraw this graph. So in some way, uh, this problem actually, let me just create this. So we have this here point C, and we have here point A. So in our problem, we are actually expected to find point B, wherein that point B is actually has a ratio it has a ratio of distance for the line segment created by point BC and for the line segment created by point A. In the problem, the distance between point A and B should be somehow it must be proportional. It can be represented by 3D, and the distance between point B and point C can be represented by the letter D. So why do we use letters in or why do we use variable? Because we don't actually know what is the distance. Currently, we don't know the distance between uh, A and C. So we will be using that D. So basically, if you look into this, uh, line segment AB or the ratio of line segment AB or the distance or the length of line segment AB and the line segment BC is actually 3D is to D, where it is actually equal to 3 is to 1, which is equal to 3 is to 1. Yan. So, in that, we can actually say in this sense that uh, from point C to point B, it is actually a quarter of the out the way towards point A. Meaning to say, we have here a length which is 4D. So graphically, how do we approach this? If we can use the distance formula, how can we solve this problem? Actually, we can use what we call the horizontal distance and the vertical distance that we already discussed last meeting. So to represent it graphically, we can actually just determine the vertical distance and the horizontal distances. So for the horizontal distance, we can actually just from this point C, okay, we can determine how long this line should be or this broken line should be by simply getting the difference between the x's or the horizontal coordinates of our graph. So that will be 9 minus 7, which is actually 16. So that will be plus 7. So 9 plus 7, that is 16. And also, we can also get the vertical distance by simply tracing this from here. So we have here this line. So that will be getting the differences again. So that will be 5 minus 1. So that should be equal to 4. So we have here a vertical distance, which is 4, and a horizontal distance, which is 16. And if we are to divide 4 by uh, by 4, actually, since we need to get that d, so that will be 1, 2, 3, 4. So quarter of the way will be 1. So that this will be the 1. Okay, and if we trace a line that will intersect our line segment initially, so that will be here. And also, if we are to divide 16 into 4, so that will be 4. So quarter of the way. So that will be 1, 2, 3, 1, 2, 3, 4. So that will be here. So we just need to trace a line that intersects our line. Basically, this point will be our point B, wherein point B will actually be equal to what's this? So we have here negative 1, negative 2, negative 3, negative 3, and we have here 1, 2, negative 3, 2. Just rewrite that. So our point B will be negative 3, 2. Right. So that is how we find or divide the line segments, or how we conclude the division of line segments using graphs. But as you may have seen earlier, I assume that the line intersects at negative 4, which is not. So how do we solve this algebraically? So in algebra, we can actually, or we can just simply identify uh, our missing point or the division point of our line segments by simply uh, looking at a starting point. By a starting point, we need to find the point in the line segment which is relatively lower than the other. In that, we can actually consider point C as our lower point and point A as our higher point. So, through algebra, we just need to write this as this. So we have here B. So for point B, we actually just need to identify or take into account point C, wherein we will be taking the x component and the y component of point C as our anchor point in some sort. So, but first, we first need to identify that the distance between point C towards point A is actually, as you may have remembered earlier, I said that it is one fourth of the way towards A. Meaning to say, if we are to get the ratio between AC or and AB, it is actually wait a second, guys. So this will be 4 and this will be 3. Meaning to say, if we have BC is to AC, this is actually 1 is to 4. So that will be BC. This one will be BC. And this will be, the whole AC will be our 4D. Meaning to say, in that, we need to consider the the distance or the proportion of the line segment that we have created from our starting point, which is point C, which is 1/4. So we will be using that. We'll be using that 1/4. So in that, let's just use the 1/4. We just need to first get the x component of C, so that will be -7, and we just need to add that to 1/4, our proportion, multiplied to the difference between the distance or the horizontal distance of AC. So that will be 9 minus -7. So where do I get that 9? So 9 here, -7 here. And for the y component, we just need to get the y component of C. So that will be 1 plus 1/4 again. That will be our ratio. And let's get the vertical distance. So we have here 5 minus 1. So 5, ay, 5 minus 1. So upon computing that, our point B will actually be, so this will be 16, okay? 16 multiplied to 1/4, that will be 4, okay? So we'll have here -7 plus 4. And also on the y component, we will have here 1 plus 1/4. Let's just compute this here. So this will be 4. 4 times 1/4, that will be 1. Okay. And adding that up, we have here 3, 2. So in here, class, we actually represented or shown how how can we determine an unknown point from a certain line segment with a certain ratio. So in that, we have here our point B, which is 3, 2. Right? So if you have any question, don't hesitate to ask me. So I know this may be confusing. So I will be posting some other examples where you can try it yourself. Bye.